After nearly 4 decades, scientists from the Southwest Research Institute SwRI have finally cracked the case of Uranus' mysterious radiation belt. And this is a breakthrough that planetary science has been waiting since Voyager 2 first observed the planet in 1986. So let's find out further more about this. Imagine looking at a puzzle piece for the decades, knowing it belongs somewhere, but having no idea how it fits. For nearly 40 years, scientists have faced exactly that challenge with one of our solar system's most enigmatic planet, which is Uranus. So, welcome space enthusiasts to a truly monumental breakthrough. Today, we are diving deep into the mystery that has baffled planetary scientists since 1980. A mystery surrounded the strange, unusual, downright weird radiation belt of Uranus. But wait is over. Things are actually. We are working on the clarity of this issue. So the team at the Southwest Research Institute, or we say SwRI, believes that they are finally cracked this decade-old cosmic cold case. So to truly appreciate this discovery, we need to rewind and picture this. It's January 1986. The world watch with the bated breath as Voyager 2, humanity's robotic explorer, make its closest approach to the seventh planet from the sun, which is Uranus. The seventh planet from the sun, that is the whole scenario was really remarkable, and this momental flyby provide us the very first close-up look at this ice giant. Voyager 2 revealed a world unlike any we had seen before. Its faint ring, its peculiar set of moon, and most striking is extreme axial tilt, and Uranus basically roll around the sun on its side. But amidst of these incredible discovery, Voyager 2's instrument also picked up something profoundly puzzling: the planet's radiation belts. So every planet with a significant magnetic field like Earth has a radiation belt, and these are regions where charged particles like electrons and ions from the solar wind get trapped and accelerated by the planet's magnetic field, forming a glowing, often double-shaped structure. On the Earth, these are the Van Allen's belt, as well understood phenomena, but at Uranus, it was really very different. So Voyager 2 found that Uranus did have a radiation belt, but they are remarkably weak and seemingly disorganized compared to what scientists expected. So the particles weren't being trapped efficiently. It was as if the belt was constantly leaking. And data from the Voyager 2 plasma wave subsystem and other instruments showed a severe depletion of these trapped particles. For 39 years, this anomaly remained one of the Uranus' most enduring secrets. Why were its radiation belts so strange? So the key of this mystery, as scientists have suspected, lay in Uranus' bizarre magnetic field. So unlike Earth's magnetic field, which is relatively aligned with our planet's rotation axis and centered near its core, Uranus' magnetic field is chaotic beast. So it is tilted almost 60 degrees relative to its rotation axis. And remember, the whole planet is already on its side. So, and it is not center. It is significantly offset from the planet's core. So imagine a wonky off tilted magnetic tumbling through the space, something very weird, you know. So this highly tilted and off center magnetic field create a truly unique and dynamic environment. As Uranus rotates, its magnetic field essentially wobble and process widely through a space. For decades, scientists knew this was the culprit, but the exact mechanism for how this peculiar field led to the leaky radiation belt remained exclusive. We had no kind of confusion, no idea about that. So, modeling such a complex and dynamic system with the conceptual power which was available in the past was incredibly challenging. And now things have just about to change, and let's do fast forward for today. So enter a brilliant mind of Southwest Research Institute led by Dr. Gina Bicrasio and her team. They leveraged cutting edge computer model powered simulations that can finally handle the increased dance of Uranus magnetic field and the charged particles around it. So their goal was actually to simulate the full dynamic interaction between the solar wind and the Uranus wobbling magnetosphere and the particle that should theoretically form its radiation belt. What they found is absolutely fascinating. Their simulation revealed that Uranus' high tilted offset magnetic field creates a series of incredible rapid and dynamic changes in the magnetosphere, and as the planet spin, the region of magnetic field that would normally trap particles get distorted and effectively open up, becoming a connected to the solar wind or even the interstellar space. So they describe this phenomena as a magnetic cliff and valleys. So imagine being a tiny charged particle trying to get comfortable in the stable magnetic trap, but every time Uranus rotates and the magnetic field around you abruptly shift, essentially creating a cliff and that you fall off, or a valley that simply doesn't hold you in. So this rapid reconfigurations means that the particles don't have enough time to get deeply trapped and accelerated into a robust radiation belt like they do on Earth. Instead, they quickly escape into space. So this is continuous rapid leakage explain exactly why Voyager 2 observed such a weak and depleting radiation belt. So the particles simply aren't held in the place long enough to build up at significant levels. So the SwRI model successfully reconciles the 39-year old observation data from the Voyager 2, which was theoretically predicted of how such a unique magnetic field should behave. So this isn't just a cool fact about Uranus. It has a broader implications for our understanding of planetary physics. So Uranus along with the Neptune represent a class of planet known as ice giant, and these are the most common type of large planet found orbiting other stars in our galaxy and exoplanets. So by understanding Uranus, we gain crucial insight into how magnetic field operates under extreme condition and what kind of radiation environment might exist around the distinct worlds. So furthermore, resolving this mystery inform the planning for the future missions, and these growing scientific interest in the sending an orbiter to Uranus to study it far more detail than Voyager 2 could actually should be happening, and knowing the specific of this radiation environment is absolutely critical for designing robust spacecraft that can survive and operate effectively there on that means on Uranus. So after nearly 4 decades of puzzling over a giant of this giant planet, a faint blurry image from the distinct probe, the picture is finally clear. And the tilted and the off center magnetic field of Uranus isn't just a oddity, but it is very reason its radiation belt are so unique. So thanks to relentless curiosity of scientists and the power of modern computation, and another fascinating secret of our solar system has been unlocked. And I just as usual would like to ask you, so what you think about this mystery and this great mystery waiting to be solved on Uranus, and in our solar system, what are your ideas? And we look forward for your comments on this topic. Let us know your thoughts in the comments, and if you found it this deep dive into planetary science is fascinating, then make sure that you hit the like button and subscribe for more cosmic revelation. So until next time, we look forward. Have a great day.